Hello, I'm talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolvin, and today we're going to talk about different types of forces and free body diagrams. Okay, so let's get going. Okay, so there are all kinds of different forces, and if you're going to draw free body diagrams to help you solve problems, you need to know, like, kind of what these different forces are. So anytime you do a push or a pull, any force exerted on an object is called an applied force, and we use capital F because that means force, as you remember, and then a lowercase a to indicate that it's the applied force. We're going to have all kinds of these, like capital F, lowercase, subscript letter here. Anyway, if you're taking these notes on a computer, if you want to do the subscripts, it's command comma in Google Docs, and that will subscript your next text, and then command comma again will turn it back to regular, just in case you didn't know. We've already talked a little bit about support force. That's the force that acts against the force of gravity. It can also be called the normal force. I usually use support force because it kind of says what it does. So F with a little f is the support force. And if you had something sitting on a desk, an object sitting on a desk, well, gravity, if you're somewhere on a planet, gravity is going to be pulling down on it, but yet that object doesn't fall through the desk because of the support force, which is usually equal and opposite the force of gravity. You also have the force of friction, so that's capital F with a little f, and that is a force acting opposite the direction of movement. And friction, oh my gosh, it went crazy there. Friction is the reason we have friction is because even the smoothest surface have little microscopic bumps, and when the two objects are touching and sliding by each other, those bumps kind of get caught on each other and they slow both objects down. Another one is kind of a special case, is the force of tension, or tension force, so force with a little t, and that's for things that are hanging. So if you had a bowling ball hanging from a rope tied to the ceiling, the force that keeps it from falling, because gravity, again, is working on the bowling ball, the force that keeps it from falling down is the rope holding it up, and that force would be called the tension force, or force of tension. And then we have everybody's favorite, the force of gravity, and that's the force of the earth pulling down on an object. Force of gravity is always in the downward direction. Support force is always in the upward direction. And we also have the force of air resistance, and the force of air resistance is kind of a special type of the force of friction. It's just like it happens as things move through the air, and you can either use F with a little AR, air resistance. You can't just do FA because FA is the applied force. So force of air resistance, I usually use force of friction just because it's one less thing that you have to remember. Okay. So let's talk about these free body diagrams. It's a sketch showing all the forces acting on an object. And you're like, I am a terrible artist. I cannot possibly draw objects and all of that. No, if you can draw a square, you are all good to go with free body diagrams. So whatever the object is, you just use a square to represent it. Not a circle, not a rhombus, not any complicated thing, just a square. And that square you're going to use to show all the forces acting in the correct direction with a proportional arrow. And a proportional arrow means that if you have a 10 Newton force and a 5 Newton force, the 10 Newton arrow to represent that force needs to be twice as long as the arrow for the 5 Newton force. So it doesn't have to be exact, it just has to be, longer, and if it's twice as long, it should be somewhat close to twice as long, twice as big. So let's do one of these things. Here's an apple sitting on a desk. Yes, I know it's a square apple. I just chose to use a red arrow to represent, a red box to represent it. You don't have to make it colored at all. So anything that is on Earth, the first force you always put on these free body diagrams is the force of gravity, because wherever it is, if it's on a planet somewhere, it's got to have the force of gravity. So you put the force of gravity in there. Okay, F little g. And because the apple is sitting still, we know, and it's not falling through the desk, we know there has to be a support force that's holding it up. So we're going to write it just like that. And we also know that because it's not moving, it's at rest, it must be in equilibrium. So those two forces have to be equal. So the arrows that represent them should be equal. Now, if you have an object that's moving, there's some different situations here. Usually the net force is in the direction of the movement, if there is a net force. And we'll get into that later. Okay. So an example, you have a ball of yarn that's being batted to the left by a cat. And here's your ball of yarn coming up right there. So what's the first force you always put on these things? Force of gravity. Now, does it say the ball of yarn is falling through the floor or falling through a table? No, it doesn't. So it has the force of gravity, but because it's not falling through that object, it also has a support force going on there. And it says that the ball is being batted to the left by a cat. So there must be a force pointing to the left, and that would be an applied force. And usually if you have something moving, unless I tell you it's in a friction-free world, there has to be a little friction. And if it's moving to the left, the friction is acting to the right. So you're going to put a smaller arrow, because it doesn't say that it's going at a constant speed. Put a smaller arrow going to the right and label that force of friction. Okay. Wow, that was a lot. You might want to replay this video just to I went through those free body diagrams pretty fast, but you'll have lots of practice. Okay, well, that's it for this time. Thanks for joining me. Have a great day.